Welcome to the lecture 6 of remainders, which is important for CAT and OMAT exam. In this lecture, we will discuss Euler's theorem for remainders. Now, before we start our lecture, I invite you to join our dedicated Telegram CAT group. I will put this link in the description. If you want to join for other MBA exams like TSNET and CMAT, then I will put these links in the description as well. Now, let's start this topic. So, this Euler theorem says that let's say there are two numbers A and N which are co-prime. A and N are co-prime. Co-prime means that HCF of these two numbers is 1. Okay. It means they have nothing in common. No factor is common between A and N. So this theorem says that A raised power phi n, we will see what is phi n. When it is divided by n, we are going to get 1 as remainder. Now, what is this phi n? This phi n is known as the tangent or Euler function, which gives us a number of numbers up to n which are co-prime to n. Okay. So let us try to understand first this tangent function. So let's say I will write a question here. How many numbers from 1 to 40 which are not divisible by, let's say, 5. Okay. So how will you approach this question? So you will say from 1 to 40, there would be 40 upon 5 numbers which will be divisible by 5. And if I want not divisible by 5, I will simply subtract this 40 by 5. I will get my answer as 40 minus 8 by, and that is 32. Okay. Now, how can we rearrange this? I can rewrite this also as 40 into 1 minus 1 by 5, right? This is another way of writing this. Now, in the very same question, if I ask you how many numbers are there which are not divisible by, let's say, 2. Okay. So, in same question, from 1 to 40, not divisible by 2. Okay. So again, same way you will say that 40 by 2 numbers would be divisible from 40, and if I subtract this from 40, then I will get not divisible. So if I take 40 common, so 1 minus 1 by 2, right? So from here you will get 20. Now, third question, what I can do is I can club them together. I can ask neither divisible by 2 nor 5. Okay. So how will we proceed this question? Now, can I combine these two? Can I rewrite like, let's say first I will find for not divisible by 5, and out of those numbers I will find which are not divisible by 2, right? So not divisible by 5 would be 40 into 1 minus 1 by 5. Let's see if I multiply by this factor. So this will give me not divisible by 2 also, right? So it means this is the number which is giving us the number of numbers from 1 to 40 which are neither divisible by 2 nor divisible by 5, right? So from here you can get 40 into 4 by 5 into half. So from here you will get 4 into 4, 16. Okay. Now what does this number signify? This particular 16 number, right? So in order to understand that, let us first prime factorize 40. So prime factorization of 40 will be 2 raised power 3 into 5 raised power 1, right? Now let's say if someone asks you how many numbers from 1 to 40 are there which are co-prime to 40, right? Co-prime to 40. Now what does co-prime mean? Co-prime mean that if I choose any number from 1 to 40, I should have my HCF as 1. Okay. Let's say any number, let's say 3. So how many numbers are such there? So can I say that since I want the numbers which are co-prime to 40, I don't want any factor common, right? So let's say if I choose 2, so HCF of 2 and 40 will be not 1, right? It will be 2. Why? Because this number also consists some factors of 2. There are 3 factors of 2, right? And this is also containing a factor of 2. So can I say that if I want my HCF as 1, if I want this HCF as 1, it means that I cannot have any prime factor common between those two numbers, right? So it means that I want all such numbers from 1 to 40 which are neither divisible by or you can say not divisible. I think that would be better word. Not divisible by any of the prime factors. Any of the prime factors of 40, right? So it means that if I want the correct answer for this, it means that I want all those numbers which are not divisible by any factor, like it should not be divisible by 2, it should not be divisible by 5. Now the powers are irrelevant here, right? So even if let's say here, you can notice here there is only 1 2 here, right? But it is still not giving me a HCF of 1. Why? Because even 1 2 is enough to you can say make it non-co-prime, right? But since we want co-prime, it means that none of those factors have to be common. It means that it should not be divisible by 2, it should not be divisible by 5, because these are the 2 prime factors available there. It means that can I rewrite this as 40 into 1 minus 1 by 2 into 1 minus 1 by 5, right? Because we saw this is the particular question that we answered in the last question, right? This neither divisible by 2 nor divisible by 5. And how did we write? 40 into 1 minus 5 into 1 minus 1 by 2, right? So now this particular answer is 40 into 1 by 2, that would be 20, 20 into 4 by 5, that would be 16. So this number is known as the phi of 40. Phi of 40. So phi of any number n, it denotes all the numbers from 1 to n which are co-prime. To n. So can I generalize a formula for this? So let's say n is p1 raised power a, p2 raised power b, and so on, where p1 p2 and so on are primes. Okay, so this is the prime factorization of n. So can I say that phi of n would be take the number, multiply it by 1 minus 1 upon p1 into 1 minus 1 upon p2 and so on, right? So finally this is our answer. This is our phi of n. You can notice one thing here, these powers are irrelevant. I simply don't have to consider them. I am only interested with the prime factors. How many prime factors are there, and I will put all those prime factors in such a fashion. So for example, let's say I give you a question, find the phi of 840. So first you will do prime factorization. You will see what are the primes involved here. So this will be 2 raised power 3, and I think if you divide this by 8, you will get 105, right? And that would be 357. So 357. Now same way you want the phi of 840, so you will take the number and you will consider all these primes, right? So 1 minus 1 by 2, 1 minus 1 by 3, 1 minus 1 by 5, 1 minus 1 by 7. So from here we will get 840 into half into 2 by 3 into 4 by 5 into 6 by 7. Now you can solve them. 7 into 5, 35 into 3, 105 into 2, 210. So 4 times. So 4 into 2, 8, 32, 6, 192. So finally our answer is 192. So this way you can find phi of any number. You will first prime factorize. First step is prime factorize. Second step is note down all the primes, ignoring the powers. So primes involved are 2, 3, 5, 7. Simply ignore the powers. And then write number multiplied by 1 minus 1 upon first prime into 1 minus 1 upon second prime, and so on, right? So this way you can get your answer. Now let us practice a few more. So let's say I give you a question of, let's say, okay, 286. So first prime factorize 286, so that would be 2 into 143, that would be 11 into 13, right? If I'm not wrong, yes. So 2 raised power 1, 11 raised power 1, 13 raised power 1. In fact, I am not at all concerned with this, right? So I will take the number 286. I will note down all the primes. So my primes are 2, 11, 13, right? So I will write 1 minus 1 upon 2, 1 minus 1 upon 11, 1 minus 1 upon 13. Simply solve them. 286 into 1 by 2 into 10 by 11 into 12 by 13. So 13 into 11, 143 into 2, 286. So this is common. 10 into 12, 120. So finally our answer is 120. Now I want to discuss a special case here. Okay, so let me discuss a special case. Let's say I want to find phi of any prime number. Let's say p. Now since this is a prime number, the only prime factorization would be p raised power 1, right? So phi of p would be, take the number and 1 minus 1 upon p. So can I rewrite this as p into p minus 1 by p? So this will be gone. So I got p minus 1. So you can notice phi of any prime number is simply, you can subtract 1 from that number, right? So for example, phi of 17 is a prime. So rather than doing all this process, you can simply subtract 1 and you will get your answer 16, right? So you can notice this as a special result, that tosient function or Euler function of any prime number is simply subtracting 1 from that prime number and you will get your answer. I hope that is clear to you, right? So let us now revise this. Now move on to this part, actually the theorem part. So I have taken two numbers a and n. I will raise my a to Euler function of n, right? I will find Euler function, and if I raise this to Euler function or tosient function, and if I take remainder, then I am always going to get 1. Now let us discuss a few examples. We will see how important this is, right? How this can help us simplify lots of questions. So here I have a question: 3 raised power 81 divided by 100. What is the remainder? Now before I solve this question, I want you to solve another question. So let's say 3 raised power 40 upon 100. What is the remainder? Right? So very first thing that we should notice is whether this number, this divisor and the base, are they co-prime? Are they co-prime? Whether these two are co-prime or not. Now checking whether they are co-prime or not is easy, right? 100 will consist of some factors of 2 and 5. So 2 raised power 2, 5 raised power 2, and this is 3. Obviously these are co-prime, right? Because no prime factor is common between them, right? It means they are co-prime. So can I apply the Euler theorem? I can apply, right? So what is the phi of 100? Phi of 100. So phi of 100, I need the prime factorization, this one. What are the primes involved? 2 and 5, right? So this is now easy. 100 into 1 minus 1 by 2 into 1 minus 1 by 5. So from here I will get 100 into half into 4 by 5. 5 into 2, 10. So this is 10. 10 into 4, 40. So phi of 100 is 40. So the theorem says that a raised power phi of n divided by n, remainder is 1, right? So a is 3, n is 100, and phi of n is 40. So remainder would be 1, right? And this is what the question is asked, right? So the correct answer is 1. I hope this is clear to you. Now let's look at this question now. Now here if you notice, the power involved is not the phi of n, but this is closer to some multiple of 40, right? 40 into 2, 80 plus 1. So can I rewrite this in the form of 3 raised power 40? Why? Because this will give me remainder of 1. So I can raise it to as much high as power as I want, right? If you have gone through my previous lectures on remainders, you must have noticed one thing, that I have always told you that your objective should be to get the remainder plus minus 1, so that even if you raise to higher powers, it doesn't impact you, right? Because those are easy to find. So that's why if I write this as 3 raised power 40 square, so this will give me 3 raised power 80 into 3 raised power 1 upon 100. So what would be remainder? Now notice one thing, I can replace this by 1 because this will give me a remainder of 1. So 1 square into 3 upon 100 remainder. So from here 3 by 100 remainder. So from here I will get 3 remainder, right? So finally our answer is 3. So you can see how easy our question became once we applied the Euler theorem, right? Let us look at a few more examples. You will understand, you will appreciate how this method is very, very important. The very first thing you should note is that whether my divisor and the base, whether they are co-prime or not. Obviously they are co-prime, right? Why? Because this will be 2 into 3 raised power 3 and this is 7. No prime factor is common, so they are co-prime. They are co-prime. So this check is done. Now the theorem says that 7 raised power 5 of 54 divided by 54, this will give me remainder 1. So let us find phi of 54. So phi of 54 would be 54 into, what are my prime numbers involved? 2 and 3, right? 1 minus 1 by 2, 1 minus 1 by 3. 54 into half into 2 by 3. So 3 into 2, 6, 9, 9 into 2, 18. So it means that 7 raised power 18 divided by 54, this is going to give me a remainder of 1. And luckily we are being asked the same question actually, right? We are being asked 7 raised power 18 by 54. So the correct answer is 1. I hope this is clear to you. Okay, let's move on to the next question. 2 raised power 2019 upon 7. Now again same thing. You can do the very same process. Check whether these two are co-primes or not. 2 and 7 obviously they are co-prime, right? They are co-prime. They are co-prime. Since they are co-prime, I can apply the Euler theorem. So Euler theorem says that 2 raised power 5 of 7 by 7, this remainder will be 1. Fine. Now, as I have discussed earlier, 7 is a prime number and 5 of 7 will be simply subtract 1. So 7 minus 1, 6, right? So 2 raised power 6 upon 7, this is going to give me a remainder of 1, but I want 2019. So can I write 2019 in some multiple of 6, right? I can write, right? So let us try to divide this by 6. So can I get 2 raised power 6 raised power 3, 6 into 3, 18, 21, 3, 6, 36 and 3. So their remainder is 2 raised power 3. So 2 raised power 6 raised power 3, 36 into 2 raised power 3 upon 7, remainder is 1. Fine. Now since this remainder is 1, I can simply replace it by 1. So can I get 1 raised power 336 into, now 2 raised power 3 can be written as 8 upon 7 remainder. Now any large power of 1 is going to give me 1. So 1 into 8, 1, 8, 8 upon 7. So 8 upon 7. This remainder is going to give me 1, right? So finally our answer is 1. So finally our answer is 1. I hope this is clear to you. Okay, let us discuss a CAT 2002 question, right? So the question is 2 raised power 256 upon 17. Now again same thing, first check whether these two are co-prime or not. They are co-prime, right? This check is done. They are co-prime, right? Because this is prime 17 and this is 2. So our theorem says that 2 raised power 5 of 17 by 17, this is going to give me a remainder of 1. Fine. Now 5 of 17, that would be 16. 2 raised power 16 upon 17, remainder is 1. Right? So 5 of 17 is 16. I hope you remember that 5 of any prime number is p minus 1, right? But I want power 256. Now 256 is nothing but 16 raised power 16 into 16, right? 16 square is 256. So can I rewrite this as 256 by 17? Can I rewrite this as 2 raised power 16 upon 17? Right? I want this remainder. I want this. Okay, now I know that this remainder 2 raised power 16 upon 17 is 1. So can I simply say that this remainder, I can simply replace this by 1. So from here I got 1 raised power 16 upon 17 remainder. Now any power of 1 is going to give me 1. So 1 upon 17 remainder. And finally our answer is 1. I hope this is clear to you. So finally our answer is 1. Correct answer is 1. So you can see how easy this question is once you apply Euler theorem. Now you can approach it in other way as well. So what you can do is you can raise it to 2 raised power 4, that would be 16, and you can use negative remainder concept, right? So 2 raised power 4 raised power 64 upon 17. So this is 16, so this will be minus 1 raised power 64 upon 17. Now minus 1 raised power even power, this is going to give me plus 1. So 1 upon 17, remainder will be 1. So this way also you can get your answer as 1. But since this was application of Euler theorem, that's why I showed you another method as well, right? So both are almost equal. They both will save you time. Okay, I hope this whole concept of Euler theorem is clear to you now. The very first thing that you should be, let's say, clear on the concept is that how to find the tangent function, how to find the Euler function, right? Both are the same names of that phi of n. The very first thing that you should know that how to calculate this phi of n, and what does this phi of n signify? This phi of n signifies that how many numbers are there from 1 to n which are co-prime to n, right? So for any n, let us say 1000. So how many numbers from 1 to 1000 are there which are co-prime to 1000? I will find those numbers, and then in order to apply our theorem, I will check whether my base, let's say a, and my divisor n, whether these two are co-prime or not. Once I confirm that these are co-prime, I can simply put here phi of n, and I can say that this remainder is going to be 1. And based on the question, I can arrange it to some other powers as well, right? The method that I showed you solving various questions. So I hope this concept is clear to you. Now I am sure that you can confidently answer these questions. Some practice questions for you. So the first question is, what is the remainder of 93 raised power 93 when I divide by 10? So what is the remainder, right? So I will put a hint, simple hint is that first you will check whether 10 and 93 they are co-prime or not. Obviously they are co-prime, right? Because this will be 3 into 31 and this will be 2 into 5. And then you can proceed, right? So please put down your answer in the comment section once you solve this question using the Euler theorem. Please don't use some other method, right? You can use other methods as well, but first try using Euler method. Okay, then you can try with other methods. You can mention those methods in the comment section as well. Okay, so I again remind you to join our Telegram cat group. Please join this cat group. You can get free PDFs there. Once remainder chapter is over, I will put all the PDFs there, right? I will simply club all the parts of PDFs in one PDF, and then I will put that PDF in the Telegram cat group. You can join XAT and CMAT group as well. So it depends on you whether you want to join or not. So fine. So thank you. If you want to support our channel, please share it with some other serious CAT aspirants. Even if they are preparing for other MBA exams like SNAP, CMAT, XAT, right, IIFT, any exam. So this concept is not exclusive to CAT, right? This is useful for all MBA exams. So you can share with those aspirants as well. This will be highly beneficial, right? So thank you.